Hi, good morning. This is a project for managing, this is the project for managing machine learning projects on Coursera. This is my project for that. In this project, the ask is that the student basically try to put in a project that they have in their own field and use the knowledge that they have gained so far. So this particular notepad that I'm sharing has basically all of the information, and I'm going to read through it. The project basically will be evaluated on opportunity evaluation, CRISP DM business understanding, a validation plan, ML system design, and potential risks in production. So for this particular project, I am using a project that is a little close to my heart, and I will explain it as we go forward. I'm a software project lead, and in software development, teams follow a whole bunch of processes, tools, steps. We have highly talented teams, but I've noticed that people spend a lot of time fixing tickets or bugs or failures when a product is being delivered. This can be in the form of internal tickets or external tickets found by the customer. These tickets can be anywhere. They can be something very simple, like simple UX issues or process issues or functional issues, system or otherwise. If so, in the last project that I worked on, we literally spent 10 years more on ticket fixing rather than feature development. If we can predict the amount of time and or the number of tickets we will get based on the existing historical data and use it in similar projects then it'll be a great thing. Basically, can we use older project data, and I will get into the features that will help us to predict what the new project is going to be. The interesting thing is, at least in the projects that I have worked in, it's an accepted fact that we will get a lot of tickets, but we do not seem to understand what is contributing to the tickets or the times that we spent on tickets. Another interesting issue is we do a lot of steps. We use a lot of tools, we use proper tracking tools, we have retrospectives, and we have inspecting and adapting and a whole bunch of other stuff, but still we cannot quantify, at least in terms of because we are not doing X, we are getting this number of tickets or things like that. We cannot quantify the value add of any step that we are doing. So for example, we do unit tests, but we do not know how much unit test is helping us in getting less number of issues. Or if we do static code analysis, how much is it helping us? Is it helping us at all? Or what can we do? And the worst part is the teams work really, really hard. We all work literally during certain times of the project. We literally work 15 hours a day, but still we get up with all of these issues, and it is very demotivating for engineers. In pretty much every project that at least that I have worked on in my career, we've always spent more time on tickets than in feature development, irrespective of whether we are SEI level 5 or something else. So coming back to the problem, is there a problem to solve? Yes, definitely there is. Can ML solve it? Yes, this is a very hard problem. Decisions have to be based on older projects. It is very hard to figure out what kind of data that we need to use, what kind of data has been collected, or how unclean or clean it is, or how pure it is. Can we get the data? Yes, we can get the data, but we are talking about projects in different areas of the company, and getting the data is going to be very hard. Where the data is stored is also another thing that we need to think about. So there will be a lot of communication that needs to happen between the teams. Does anybody care? Everybody should, especially the project managers, the senior management and quality teams have goals to improve this particular metric. So everybody should care about this. Is the problem worth solving? Yes, it's definitely a problem worth solving, because the amount of time we spend, which basically translates into dollars, is in millions or thousands and millions of dollars if you really take the size of projects that I have been working on. Now let's come to crisp DM understanding. So defining the problem. So when we are trying to define the problem, the first thing that we need to identify is the target user. Who is the target user? The target users are basically project management, senior management, including quality, and all the teams, all the engineers working on the project. Problem. The problem statement is pretty simple. Use existing project data to predict time spent on fixing bugs and understand what, who, where is contributing to the problem. Why it matters. In the last project where I did my analysis, as I mentioned, the time spent on tickets or bugs is usually years more than the time spent on development. And interestingly, nobody seems to know why. And when this question is asked, everybody gets defensive, but we still do not know the reason as to why. The current state. Nobody is looking at this particular data, so this is a very huge gap. As far as I know, nobody is solving this, and unfortunately it has become very normal, so basically it is not solved today. For defining success for this particular project, expected impact is identify features or independent variables contributing to the problem and improve them. Basically, what is the pattern that we are seeing? What are the independent variables that will help us in improve this? So earlier I mentioned unit test or static code analysis. True, we run them for every project and we fix them, but in most cases, is it helping in the long run is something we do not know at this particular time. Metrics, reduce time spent on tickets, failures, and bugs. Again, these failures can be tickets, bugs, process, functional, UX, it can be anything. Target reduce time spent on tickets, failures, bugs by X%. I put X% because I cannot give a number at this particular time. Constraints. The goal is that once the tool or the model is available, the prediction should be available 1 to 2 hours after inputting the data. Identify relevant factors. Input is needed from multiple teams, and this could be a huge issue. Older projects have been run on different tools. Sometimes people use Rally, sometimes use Excel sheets, and collecting all of the data is going to be a big deal. For this, we will definitely need a lot of senior management support and sponsorship. Data understanding, sources. Data should be collected from different tools that the older projects are using. This can be a project management tool like Zira or Rally or Excel spreadsheet or something else. Considerations, we should think about how, what, where, why data we should collect. Validating the data. This is something that I'm still working on. So some of the features that I was thinking for this particular for this particular project or for this particular POC or machine learning is team size, age of the project, which tool set was used, was unit 10 test done and where they fixed, how much static code analysis was done and where the issues fixed, how many locations is the team located on. You know, we all work in global teams. Pretty much any project that I work on is there on at least 5 different countries at a different time. So the number of locations, the culture and all of that matters. So the number of locations is really an important feature. The type of project, you know, is it a mobile application? Is it a web application? Is it a hardware related and a software related project? All of these things need to be taken into consideration. So that is what, when it comes to defining the problem or crisp DM business understanding. And the next comes is the solution validation plan. From a solution concept, the idea is that we have to come up with a big set of features, like I mentioned earlier, and need to understand what is contributing to the software project quality. For this, I have to talk to multiple teams, multiple stakeholders, PMs, development leads, engineers, test teams, senior management, quality teams, delivery managers, and a whole bunch of other stuff. And all that input needs to be converted into a model. At first look, I felt multiple regression will be a good point, but multiple regression, if the constant or y is equal to mx plus b, the constant is high, then it might not help us in that regard. So I was also thinking of trees or a combination of multiple problems, multiple models for this particular concept. I have read a few papers on this particular topic, but I couldn't find something that will work for us at this time. And this is something that I'm still continuing to work as we speak. From a validation perspective, since one software project or one release of a software project will be one record, we will not have more than 100 to 300 project related historical data. In short, the data will not be in millions, but it will be in hundreds. I plan to use 70% for training and the rest for validation. A web page will be the front end of this particular project, and the plan is to design it that way. From a system design perspective, this project will be using the following ML system design concepts. It will be a cloud-based or a cloud ML. In short, the data will be in a cloud or a server, and latency is not an issue. It will also be online learning, because the user will be able to enter the data into web page and get the output immediately, at least relatively. Continuous training needs to be done using new data points as they are available. Projects are constantly changing. New releases are added, new data is available, new people are added. So nothing is constant. There is constant attrition of engineers. The scopes keeps changing. So this is a constant online learning project, is the way I see it. Even from a prediction standpoint, this will be an online prediction, and prediction will be pretty much available pretty much on request. This will not be a batch kind of a thing where predictions are available periodically, because the moment we enter the data, we should know what is going on and go from there. From a potential risk standpoint, data drift could be a potential issue. All software projects have lots of commonality, but at the same time, each project is unique in its own way. To the tools used, to the culture of the team, to the data collected, and a whole bunch of other stuff. Also, the data that is relevant on older projects might not be relevant on the new one, as we keep using new languages and new tools and new tools. In the old, we used to write millions of lines of code, but now we have so many tools which kind of auto create the code for us. So all these could be potential issues. Latency is not an issue for this project, because the expectation is we will not be having millions of records, more than like hundreds of records per se. Concept drift could be a issue as well. Please let me know if anything I missed or if I need to add more, but and we will go from there. Thank you for your time. Bye.